Welcome to the assembly videos for the Reprap Wilson II 3D printer. This is part one of the videos for putting together the Wilson II, and in this step I'm going to assemble the Y-axis. So that's the part of the printer that sits flat on the table and holds the print bed. So I have here all of the plastic parts for this step, along with the two 1/2 meter long 10 millimeter diameter smooth rods and two 2020 aluminum extrusions the same length, one of the stepper motors, one of the in-stop switches, and the wooden print deck. And then over here on the side I've got bearings and belt and nuts and bolts that we'll use along the way. So assembling the Y-axis is pretty straightforward. Get either one of these Y-ends, the larger pieces, and put the aluminum extrusions one on each side, and the same with the smooth rods. Make sure that all of these are seated all the way down into that plastic part, and then just leave it sitting upright like that so that it's steady. And get 12 of the T-slot nuts, and you put 2 of these into each side groove of each beam and 2 in the top groove. So none in the bottom grooves, but 2 in every other one. Now get the 4 brackets. These are the plastic bracket that's going to hold the Y-axis to the rest of the machine, and we're going to put 2 on each of the extrusions and orient them like this so that the pointy side of this bracket goes towards the bottom of the Y-end, which is the end with these holes on the bottom, and the 2 on each of the extrusions should be turned around facing each other like this so that the flat sides are towards each other. Now turn that around carefully and get 4 of the linear bearings. So these are LM10 UU standard steel linear bearings, and put 2 over each smooth rod. Then get the other Y end. This one happens to be the motor because I started with the idler end, and that gets fit over the top sides of these 4 pieces, just like the other end. Push it down, make sure it gets well seated also. Then hold both sides so that it doesn't fall apart at this point, and just carefully set it down on the table. And you may have to slide these out of the way, so if they aren't smooth, just be careful that you don't accidentally pull everything apart, otherwise you have to start over. And then get 10 millimeter M5 screws. These have a hex cap, but yours might just be Phillips. And you're going to put one through each of these outer holes on each of the Y ends. So there's 2 on the outside and 2 on the inside on both sides. So line up one of the T-slot nuts. Sometimes a magnetic tipped screwdriver is really helpful here because you can grab those T-slot nuts if you need to. Start with do 1 on each side so that, and we can move everything around a little bit easier without worrying about it falling apart before we get them tightened. And as you tighten, just again make sure that the two sides are pushed in all the way. Okay, we've got those 8 screws in on the ends, and now if you turn the assembly upside down on, right side up, on this side of the 4 brackets is another hole that you want to put another 10mm screw through each of those T-slot nuts that we put on the top side. And there should be the smooth rods are offset just a little bit from the extrusions so that you can get your screwdriver or your Allen wrench straight down onto there. Now for now we don't really have to tighten these down because we're going to need to move these back and forth later, but just pick a spot and kind of tighten them enough so that our screw won't fall out and we'll lose it. Okay, now we can set this over to the side for a minute and get the printing deck. Now what I have is the laser cut version, and if you don't have this, you can also just make this piece from 1/4 inch MDF, and the drawings for either version will be in the design file repository, so you can find that there. But this version, it's just more convenient because the holes are already in place. There should be 8 holes total, and if you don't have the laser cut one, you just need to line up the heat bed and the this piece, the Y table piece, in order to figure out where to pre-drill those holes. So I'll skip that since this one's already has that done. So getting this piece and the Y table, you want to line that up right here, or as it's shown in the documentation, and then just fasten that in place with a M3 screw with 4 M3 by 14mm screws and M3 lock nuts. And you don't have to use lock nuts for this step. You could use a regular hex nut if you want. Either one I think will work fine. Since the print bed moves a lot, I always like to use lock nuts if I have them available for pieces of the printer that are going to see a lot of vibration. Okay. Now get the axis from earlier, and I want to set it upside down on top of this assembled print bed, and line each of these linear bearings up with one of the grooves that's in the Y table, so that it sits. It should each rest inside one of those little cavities. And then we'll use small zip ties through each one of these to mount the two together. Like this through each one. I forgot to mention that when I placed this on top of the Y table, there is a front side. There is a side that needs to go towards the front of the machine, and the front of the machine is the idler end, is this side that's completely flat. The other end will have the motor, so before you start putting the zip ties in, just double check and make sure you've got it turned around the right way. And then we can trim each one of these so that it doesn't have a lot of extra stuff. Okay. Now we can attach the motor, the Y motor, so get your stepper motor. And you'll need four 10mm long M3 screws for this. And I've mounted it so that the wires from the stepper motor come off on the right side, towards the right of that end. I'll show you why in a second. And next, get the end stop, and the end stop's going to go, it's going to fit into this space, and start with the wire end and feed it down through this hole. And then you push the end stop into place here so that the lever arm is pointed up and towards the print bed. And then get two M2 by 16mm screws and fasten that into place with one in each slot through the end stop. Now once that's in place, if you slide the print deck towards it, it should just hit that switch. Just like it should just be lined up perfectly like that. And that switch is what will tell your electronics when the printer is moved all the way to the back of the Y-axis. So that's important. Now the wires for both the motor and the end stop I've got coming out right here together, and in the motor end there's a small slot, and the purpose of that slot is so that we can take a zip tie and we can secure all of these wires right here so that they have some strain relief, so that anything that we're doing later won't pull against these and end up pulling either the wires from the motor or the wires from the end stop. So while it's easy to get to, just put a zip tie right there and tighten it down nice and tight. Now get the pulley for your motor. This is a GT2 or a 2mm pitch pulley, and we want to put it on our stepper motor while we're here, and it needs to point. You actually want to put the side with the set screws that fasten it to the shaft of the motor. You want that side to actually be up, and that's what's going to make it so that our belt lines up the best. Otherwise it'll be a little too high. So to tighten that, I have a smaller Allen wrench, and if your motors like these have a D profile shaft, which means there's a flat side on the shaft, you want to make sure you line that up with one of the set screws, because that will hold it the best. And then tighten the other one. And we'll adjust the height of this if we need to, but for now just set it so that the top of the pulley is flush with the top of the shaft of the motor. Okay, now turn the whole thing around so that we have the idler end towards us, and get the this piece, which is the belt tensioner for the Y-axis. There's another one for the X, but and they're mostly identical, but this one has a Y printed on the side so that it's easier to tell apart. And two of these plastic bearing guides, or belt guides, and a 624 bearing. So this is a roller skate style bearing. And we'll need an M3, a fairly long M3 screw. This is a 30mm screw, and nut, and put this nut into this little groove in the side of the tensioner, and then just hand thread this through there until it starts to come through this end in this slot. Then put your 624 bearing in between these two little pieces like that, and it will fit in this yoke. And then using a 20mm M4 screw and an M4 lock nut, just tighten this enough so that you don't want to over tighten it and compress this yoke, but you want it just engaged enough so that the M4 screw goes through the locking part of that nut, so that this will then spin freely like that. And then this whole thing just slide into this groove right here, and then get another M4 by 20mm screw, and it goes right into that hole in the top in order to hold it. And then if you have an M4 nut, which I have here, then you can turn this upside down again, and way back in here you'll see the bottom of that M4 screw, and you can get this nut on there. And then that won't work its way out. And this should then easily slide back and forth about maybe a centimeter or so. That's what's going to allow us to adjust the tension on the belt. So for now, you want this screw turned most of the way out so that this can go in as far as possible. Now we're ready to put the actual timing belt on. So to do that, flip the Y-axis upside down and get your timing belt. This should be about 1 meter long. And if your belt is, say, 2 meters, because that's what you're starting with, don't cut it yet. Just start with the whole 2 meters. And so we want to start here in the middle at this Y table on either side. And the belt goes through this groove. Here, I'll try to get a close-up. So through the groove with the teeth facing against, the teeth of the belt should face against here so that they grab, and then back around and then out the same direction that it came from. And just adjust it so there's just maybe 1/2 inch or so of belt sticking out there. And then get another zip tie and tighten it. Like that, so that the belt is pinched. And also make sure to work the belt down as far as you can into that groove. It's a fairly deep groove. Now take the loose end of the belt and go through the pulley. And then it'll pass around the idler, I meant. And then we'll go around the pulley, so just get it across there. And then it's going to come, and obviously the teeth from the belt should be engaged with the pulley. And then pull it, kind of tight, and then wrap this side just like you did the first one, like that. And if you have a bunch of extra here, then now you can trim it. Okay, so now our belt is in place, but you can see, if we turn our motor, it moves the bed, but this is really not tight at all. So that's where our tensioner comes into play. Now, if we just turn this outer screw, it will pull against. It'll push this screw against that downward one, and that pulls the whole thing back until it's nice and tight. And that looks pretty good.